Welcome to the Daily Space Weather. I'm your host, Dan, aka smAsho. And we're looking at Earth's life giver, the star around which it orbits. And this is the ultraviolet emission spectra of ionized helium. Here's another view of the same star. Is it your personal favorite? Leave us a comment. We've got a couple of sunspots here. Sunspot 2824. Over here, sunspot 2825. And over here, sunspot 2826. 99% chance this will get a name also today. And lots of space weather in the news. Let's take a look at the colorized magnetogram to see how those sunspots have been evolving over the past 24 hours. Sunspot 2824, the main sunspot here, has remained rather stable. And you can see some areas of activity ahead of it forming there. Sunspot 2825 remains stable as well. At least one sunspot going to be named in front of sunspot 2824. In my opinion, that'll be sunspot 2826. Here's a close-up of the northern hemisphere. In 1600 angstroms, this is just extreme ultraviolet light. There actually is a plasma filament up here. You can kind of see this dark area here up in the northern hemisphere. Great view of the northern hemisphere there in that wavelength. And what about solar storms? Well, solar storms can cause all kinds of issues such as power grid failures, communications breakdowns, even some human health effects can happen. And if you're doing a flight on a plane that goes close to the poles at the time of a geomagnetic storm, you could receive like 100 times the amount of radiation you'd receive from a normal X-ray, as opposed to only 10 times the amount of radiation you would normally receive. Sometimes these solar storms make it to the Earth as quickly as about a half an hour after solar flares and coronal mass ejections occur. Typically they take a couple of days, and we're expecting one later today. You'll find all kinds of information about this on the internet, and please don't blame China and Russia when power grids start to fail and communications start to break down. It's probably not a cyber attack. So here's a phys.org article about it also. This is in the astronomy and space section, and you may not be aware that modern mankind has done all kinds of things to fortify itself versus this sort of natural phenomenon. And they are largely invisible and harmless, although people with health conditions can find correlations between exacerbations of certain conditions and solar storms, especially when you get to about a KP of 8. Very, very high levels of geomagnetism induced by incoming solar protons. I'm just going to let this article scroll here in case anybody wants to read it. Again, this is on phys.org in the astronomy and space section. In March 1989, a solar storm over Quebec caused a Providence-wide outage that lasted 9 hours, according to Hydro-Quebec's website. A 2017 paper in the Journal of the American Geophysical Union predicted blackouts caused by severe space weather could strike as much as 66% of the U.S. population, with economic losses reaching a potential $41.5 billion per day. And the most likely places to see power outages in the U.S. are probably California and around the Great Lakes region. The farther north you are, the more voltage is likely to be induced in your power grid. And we'll actually show you where the links are to that if you want to watch that empirical data in real time. We'll show you that momentarily. So both Obama and Trump did do some things, such as the pro-SWIFT bill, to help to improve forecasting and measurement of space weather events. We've beefed up our skills as well. It's part of the reason why our channel exists. We've been forecasting coronal mass ejections before they even leave the solar corona. And how we do that is still a trade secret, as we've got to write a paper about solar cycles and this forecast first. So here at the Smash News Network, we're very interested in things like phenomenon with predictive value. And if you want to read more about our mission, head to smashomash.com/forum/mission, and you can read all about it. The next thing the Smash News Network least busted name in news will cover are the positions of objects in our solar system. So here you have a current situation. There's where things will be in a week. It looks like a full moon tomorrow. So a full moon, supermoon, blood moon, lunar eclipse going on tomorrow. But we'll be probably not even covering that, as there'll be too much information about geomagnetic storms to talk about in the daily space weather and our other content, actually, as well. Here's a star chart. I faced mine to the south. I use in-the-sky.org and put in my location, as I'm interested in what's going on above my head. This yellow line here is the ecliptic, the path which the sun takes across the sky. If you're up before dawn, you may see Saturn and Jupiter. The radio flux down to 73. So a surprising dip in the radio flux despite more activity in the northern hemisphere of the sun. Here's a one-year chart of the 10.7 centimeter radio flux, which is this black line. Red line is the sunspot number, and the blue line is the Potsdam Interplanetary Magnetic Field Index. So here you can see NOAA's forecast. I'm expecting some ejecta to arrive earlier than this. NOAA forecasting the geomagnetic unrest to begin around 1500. I would say any time now we could actually see some ejecta arrive, as the coronal mass ejections we saw around the 22nd and 23rd, they were at all different speeds. So we saw some low speed ones and some high speed ones. We're not really expecting this to arrive in one pulse. We're expecting multiple pulses. Let's check out seismicity. So global seismicity here is the past 90 days. A great resource here on Volcano Discovery. They're also showing year to date and even previous year breakdowns if you want to check that out. So here are the 5+ magnitude quakes. We saw one here in southern Africa and one south of Mexico there, as well as one north of New Zealand. There are the 4 magnitude quakes. I like this breakdown a lot. Shout out to Mary Wright, one of our viewers and patrons. There's a deep quake near Fiji. We're just going to scroll up the list here. No major quakes over the past 24 hours. And if there's anything we don't comment on in the video, please leave us a comment in the comments section. Also, Indonesia saw a deep quake, as well as New Zealand. Actually, the area north of it there, adjacent to the Kermadec Trench. And Chile saw a deep quake. 3 deep quakes here. The last 3 quakes coming in on the list here, all deep ones. Between 106 and 592 kilometers depth there. That one right, looks like it's right on Fiji, actually. It is east of Fiji, coming in at nearly 600 kilometers depth there. New study shines light on hazards of Earth's largest volcano. Well, it turns out there is a correlation between 6 magnitude earthquakes and the world's largest volcano, Mauna Loa. So Mauna Loa is about 9 kilometers tall if measured from the bottom of the seafloor to its top. It's the world's largest volcano. And it turns out that it's related to 6 magnitude quakes. So if you see a 6 magnitude quake, that could be associated with a trigger event of Mauna Loa. This phys.org article is in the Earth section if you want to check that out. Also, Etna's been erupting. Here's a great image of May 24th, last night's latest paroxysm. a lava fountaining event. Let's see what else is on the list before we take a look at a live webcam. So Etna, 48 hours after the previous paroxysm, produced another one. And a plume of ash came from there. Suwanosejima also exploded. 6,000-foot ash plume there. Luatolo in the Lesser Sunda Islands, flight level 070. It's produced a 7,000-foot ash plume. And Krakatoa is now back on the list. The daughter of Krakatoa has been exploding and producing a 6,000-foot ash plume. Dukono also exploding, flight level 080. It's 8,000-foot ash plume there. Sangay, 18,000-foot ash plume over it in Ecuador as it explodes. Revenador in that same nation of Ecuador. Volcanic ash not observed in imagery. Doesn't mean it's not erupting. Sabancaya exploding, 25,000-foot ash plume. Nevados de Chilean, intermittent emissions. And some seismicity going on at Nyiragongo. So volcanic tremors here going on. Could be an indication that this thing will erupt some more. The slopes of Nyiragongo are infamous for many fissures and ground vents accumulating sometimes deadly concentrations of highly toxic gas. So we'll be keeping an eye on Nyiragongo. Here's a webcam of Etna. Looks like it's pretty calm right now at the moment. And you can find the live webcams tool on volcanodiscovery.com. And we'd like to remind you to not pole vault the caldera. Not everybody can be like Steve Stimpak here, silhouetted on that imagery. Pole vaulting calderas is vastly too dangerous for you to likely do. So even if you're a track and field star, at smAsho.com, we'd like to remind you not to pole vault the caldera. Next, back to space, the GOES 16 showing a reduction here in solar flaring. One M-class flare still appearing there on the 3-day chart as the Earth-facing quiet is in effect. No major flares over the past 24 hours. No spikes in the proton flux. And we may see some as coronal mass ejections arrive. We'll be keeping an eye on it. And when I say eye on, well, the pun is intentional. The GOES magnetometer over the past 3 days here, a little spiky, and we're going to see some major spikes in this as the coronal mass ejections strike. There is also perhaps a weak coronal hole wind stream in the process of arriving. We'll get to it. First, let's take a look at the heliospheric current sheet. And we have a South Pole-oriented current sheet just snapping through, coming our way. It could be here by tomorrow, and it could absolutely affect the way the coronal mass ejection arrives, as we're expecting an ongoing coronal mass ejection event here over about a day and a half, about 36 hours. It will likely take for all of the ejecta to be done striking the magnetosphere. Here's a line of sight ecliptic plane field plot. It's essentially the same data gathered from 51 ground-based magnetometers, part of the National Sunspot Observatory, as well as magnetometers on stereo A and stereo B. A great 3D visualization there, also showing you the solar magnetogram. Here's the sun's B field shown in blue, as well as coronal holes. And I think we did see some coronal hole wind from this coronal hole right here, this South Pole-oriented red-colored one. We've also got a trans-equatorial coronal hole just rotating in here, associated with the North Pole. Actually, it looks like it's retracted a little bit. Anyway, lots of pressure built in the Northern Hemisphere in the past, maybe, I'll say, month. And next, let's look at an animation here of detected coronal holes and sunspot groups. So this group ahead of sunspot 2824, it could be named as 2 sunspots. I think it's more likely to be as 1, but it could actually get 2 different designations. It could be 2826 and 2827. But at least one of those will most likely get named today. KP index currently at 0, as we saw some very weak solar wind yesterday. Expecting a rather rapid ramp up in the solar wind. Let's take a look at the real-time data here. So over the past about 10 hours, we did indeed see an uptick in the solar wind density, which is consistent with what we would expect from a rather weak coronal hole wind stream. If we see this drop off and the speed go up at the same time, that could be a coronal hole wind stream, or it could be a coronal mass ejection striking. We'll attempt to keep you posted on that. Next, let's look at 4 hours of data of what's going on in the geospace. And we can expect a major intensification here of the magnetohydrodynamic pressure when those coronal mass ejections arrive. And we're expecting at least 2 of them to be striking the Earth, probably more like 3. And since that refreshed, I'm going to let that play through. And that's 4 hours of data. You can see a very small increase in the pressure here toward the end of the video. Next, we'll show you geospace delta B ground magnetic perturbations, bringing you a little closer to home here. And you can see some perturbations here associated with the South Geomagnetic Pole, which is someplace down here, someplace in the southern Indian Ocean, south of Australia. And the main perturbations in the north here are closer to the Canadian pole as opposed to the Siberian. And if you're a new viewer, yes, there are 2 north poles currently on planet Earth. It's a geomagnetic excursion. And we've streamed live for Twitch once again, twitch.tv/smAsho if you want to see these videos when they come out in live format. Thanks to our new followers over there on Twitch. Again, great live streaming platform, twitch.tv/smAsho. Thanks to our YouTube viewers as well. And if you're viewing on Twitch, don't forget to subscribe over on YouTube. Most of our content is there. We're also on BitChute. There are some exclusive videos there as well. Welcome to the Neo Renaissance. Visit our links, support our channel. We saw the writing on the wall years ago, so we built our own website. You can find our social media there as well as our merch and our forum. And again, if you'd like to read about our mission, smashamash.com/forum/mission. Next, let's thank our patrons. Hey, patrons. Thanks for increasing the probability that these videos will continue to exist and remain publicly visible. Patreon.com/smashamash. Thanks for the nice comment yesterday, Evan. Thanks again to all of our patrons. Patreon.com/smashamash if you want the earliest alerts and all kinds of other information nobody else in the world sees. Consider becoming a patron. By the way, patrons are listed in order of total lifetime contribution. So this is today's cosmology segment. Let's get to it. First thing we're going to look at is cosmic rays. We're going to look at 7 different cosmic ray monitors. So here is Apatity's neutron monitor. And you can see cosmic ray flux has been pretty flat here over the past 30 days at Apatity, at least average. Barentsburg also flat over the past 30 days. Next we'll go farther south to Athens, Greece. There's Athens' neutron monitor. Pretty consistent cosmic ray flux here over the past 30 days at Athens as well. Let's go even farther south to Mexico City. Small downtick there at Mexico City over the past 30 days. Here's Oulu, Finland. And Oulu is also flat over the past 30 days. Here's DOMC Antarctica. A little uptick here at the southernmost cosmic ray monitor stations. DOMC Antarctica showing a little uptick over the past 30 and especially over the past 5 days. DOMC Antarctica showing essentially the same chart, so that's some corroborative data there. A little increase in cosmic ray flux at Antarctica. Next, today's random number is 88, and it coincides with Quasar 4C 28.07. Let's take a look at it in some wavelengths. Here it is in X-ray from the Chandra X-ray scope. And it looks quite differently in infrared. There it is in infrared light. It looks essentially spherical. Is there any hydrogen gas there? Not a very gassy region for hydrogen. How about in red light? There it is in red. And let's also take a look at it in blue visible light. You can see some differences there. And let's see if it shows up on the XMM Newton. Anyway, that's today's, quote, random, end quote, cosmology object, Quasar 4C28.07. Entry number 88 on the Neil Gorell Swift Bat X-ray Observatory, the Burst Alert telescope that monitors X-rays. Here's the 30-day chart of that. And you can see over the past 16 years, it's a pretty consistent X-ray source with some significant variations as well. And if you want to follow your favorite transients, head to the Neil Gorell Swift Observatory. For instance, you may be interested in what Cygnus X3 is doing, especially if you're a regular viewer of the channel. Cygnus X3, high mass X-ray binary. There's the last 30 days of it. And if you want to read more about Cygnus X3, head to smAsho.com/forum in the cosmology section. There is an entire forum thread about Cygnus X3 Deneb, the tail of the swan. So here comes a tomorrow super blood moon. And today's astronomy picture of the day is a moving picture. You can find it yourself at apod.nasa.gov. Here's some imagery of a lunar eclipse. Next, let's talk about the birth of stars. Have we ever really seen stars get born, folks? The answer is, well, a lot of people believe we have, and a lot of people believe we haven't. As the life cycles of stars are not really fully understood. However, 36 dwarf galaxies all seemed to light up at the same time. So the belief that stars were born there may be a little bit outlandish, but in any case, interesting that we saw a dozen galaxies separated by up to 13 million light years simultaneously accelerated their, quote, birth rate, end quote, of stars, according to a paper led by Rutgers in the Astrophysical Journal. It appears that these galaxies are responding to a large-scale change in their environment in the same way a good economy can spur a baby boom. We found that regardless of whether these galaxies were next-door neighbors or not, they stopped and then started forming new stars at the same time. So this has to do with their emission spectral outputs. And again, I don't really... Mankind has never legitimately seen a star get born or a star die. We've seen stars wink out and stars turn back on. If you look at old plates, you may see stars that used to be there and are no longer there. Other stars that weren't there and now are there. What causes a star to emit light or stop emitting light? That could be an interesting cosmology question for our viewers. And of course, there are certain intrinsic properties of stars that I believe are involved in this. I'm just letting the article scroll here in case anybody wants to read it. It's got links. Again, it's from the Astronomy and Space section on phys.org. And here's some close-ups of the dwarf galaxies involved in this study, of all different shapes, and separated by up to 13 million light-years distance, yet showing similar changes in their overall emissions. That's today's cosmology segment. We'll have to say goodbye to Twitch. Bye, Twitch. We'll bring you back for the meteorology segment. Next, let's blast through a whole bunch of other data. Here's a diagram of the Earth's Van Allen belts. And now we're going to talk about electrons. They have the ability to charge up spacecraft, satellites. We don't see it happening yet. We could see some major happenings coming soon. Here's the 1-year chart of the greater than 2 mega electron volt flux. Electron flux, that is. That's from solon.info. Here's a 3-day chart. We did get a little bit into warning levels yesterday. Our patrons would have known about it quite quickly after it happened. Patreon.com/smAsho. Here's the forecast for electron flux. I would tend to agree with this as, again, coronal mass ejections are about to arrive. The green boxes are the forecast. Here's a total electron content forecast, a visualization of the electron density above your head. And it's showing the whole air column and the most likely spots of GPS errors here on planet Earth. Here's another diagram of the atmosphere. We're showing you this for the F layer. The F ionosphere, located at about 300 kilometers altitude. Here is a visualization of that. The vibrational frequencies. And we're seeing quite a discharged charge situation going on here. A highly discharged ionosphere is the current state right there. You can see very low vibrational frequencies there, even on the sun-facing side of the planet, and then suddenly getting to much higher vibrational blobs. So each one of those blobs represents 1 megahertz difference in vibrational frequency of the ionosphere. And again, that's located about 300 kilometers of altitude. It's in many ways the bridge between space and Earth. Above it is more like space, and below it is more like Earth. Anyway, there's the current image at 9:15 Universal Time. And check out the heavy winds in the southern portion of Greenland. And it's time to bring Twitch back for our meteorology segment. So let's take a look at that again. Strong winds here south of Greenland, the southern portion of the island possession of Denmark, the autonomous Denmark property here, showing nearly 60-mile-per-hour winds across a large portion of the southern part of the island. And let's zoom out and show the rest of the surface winds here for the Western world. There you have that. And here are the jet streams of the West. Quite extreme bends in the jet stream here just south of Greenland. A 180-degree bend there over the North Atlantic Ocean, as well as doubled up jet streams there over the North Central Atlantic, doubled up jet streams over Northern Africa, and extreme bends over places like France and Germany. Here are the jet streams of the Eastern world. And we'll also show surface winds to give you a global snapshot. Strong winds once again showing up here off the coast of India. Pushing hurricane force winds there. Continuing on, here's lightningmaps.org. I'm always interested in where the active cells are when I hear thunder. And we've got some active cells here once again over northwestern Kansas mainly. Also some in south central Kansas. Anyway, there's your global real-time lightning map. Here's your NASA GOES lightning mapper. Continued extreme lightning here in southern Mexico. That's about 3 days worth of extreme lightning. Countdown to the solstice. We're going to be streaming live for it. Where will you be? Hopefully viewing our live stream. What will you do with the last 26 and a half days of your spring? Next, looking at pressure cells here. Here are pressure cells. According to windy.com, we're going to advance this into the Euro forecast. There's the Euro forecast for pressure at 1 p.m. Eastern Daylight Time tomorrow. Here's a U.S. Doppler radar map. Strong storms here over northern Texas, as well as some heavy storms there in Minnesota. Just moving into northwestern Wisconsin. Also some concentrated systems there over eastern Colorado and south central Kansas. Hopefully nobody ends up in Oz. Here is the cloud layer. It's the NASA GOES shortwave radiation map. Here's the water vapor map. And it looks like some dry mass of air is going to finally start to move this atmospheric pond. Seeing a bit of a pulse there behind all of that moisture. It looks like it's going to keep moving to the northeast. And some funky north to south flow happening here over the mid-Atlantic states. Again, there's the cloud layer. There is the U.S. Doppler radar. And that's today's meteorology segment. Thanks for tuning in, Twitch. And again, if you're viewing on Twitch, make sure you check out our YouTube channel. Most of our content is located there. Here come daily space weather bonus features. The latest hydrogen alpha imagery from the ground-based El Teide Spain Observatory. Looks like some clouds moving over their 6,562.8 angstrom telescope. And here come the additional bonus features, the high-resolution intensitygram. You can see likely sunspot 2826. And possibly even sunspot 2827 forming behind it. This one will most assuredly get a name today. That's sunspot 2826. I'm calling it. And here's the colorized magnetogram. It looks like 2824 has actually degraded a little bit. This is already a beta class sunspot here, so this one could produce some flaring. Sunspot 2824 could still produce some flaring as well. In fact, let's take a look at that again. There are some opposite polarity umbrae there, folks. But these South Pole umbrae, this is South Pole here, they have degraded a bit. The main umbra is indeed North Pole. So sunspot 2824 has actually shrunk. And we'll close out today's daily space weather video with two more close-ups of the Northern Hemisphere. Here's 94 angstroms ionized iron. And another wavelength of ionized iron. A different number of electrons. It's 171 angstroms. So be prepared, folks. Realize that there is some weather from space coming. If somebody tries to blame China or Russia for it, take it with a grain of salt, maybe a truckload of salt. Thanks for tuning into the video. Don't forget to check out the rest of our videos on our playlists. We'll talk to you soon. I've been your host, Dan, a.k.a. smAsho, and may that solar wind be at your back.